This video will look at radians and degrees, coterminal angles, arc length, and area of sectors. First, let's look at the relationship between radians and degrees. Radians and degrees are just two different ways to measure angles, just like inches and feet or cups and liters. We all know that a circle, right, a full circle, right, if we go all the way around, is 360 degrees or 2 pi radians, right? That's another way to have a full circle. So that establishes our idea that 360 degrees is equal to 2 pi in terms of radians. Now, if you want to know more about the idea of what a radian is, I did find a video that explains it nicely and I attached it in the folder. But basically, 1 radian, right, an angle that measures 1 radian is created when the radius of a circle is the same as the length of the arc that's created or the arc that it subtends. So 1 radian in terms of an angle measurement is the same when this, and this are all the same measurement. But if you're interested, again, go in and look at that video. So that idea of 360 degrees is the same as 2 pi. If we simplify that, that brings us to 180 degrees is equal to pi or pi radians. Degrees will always use that symbol, the little degree symbol. And then radians, either you can write the word radians, you can write the word rad, or often it doesn't have a unit. So if you see an angle measurement and it doesn't have a unit, it means radians. Again, degrees, we want to always write the degree symbol. So now, just like you always remember 1 foot equals 12 inches, I want you to remember that 180 degrees is equal to pi or pi radians. And this conversion is what we will use when we change from degrees to radians or radians to degrees. Converting from degrees to radians, we're going to multiply by pi over 180. And the opposite, if we're converting from radians to degrees, we're going to flip that and multiply by 180 over pi, right? If we want to end up with degrees, we want our degrees to be in the numerator. So let's look at 2 examples. Let's change 60 degrees to radians. So we start with our 60 degrees, and I'm going to multiply it by our conversion factor. If I want to end up with radians, I want to put my radians or pi radians in the numerator, and I'm going to divide by 180 degrees. You can also see that the degree symbols here and here, they will cancel out, and we'll be left with 60 goes into 180 3 times, and that's pi over 3 radians. So 60 degrees is the same as pi over 3 radians. Now let's convert the other way. If we want to change pi over 6 radians into degrees, I now want to end up with degrees. So I'm going to multiply by 180 degrees over pi radians. My pi's will cancel, and I will end up with the negative sign will stay. 6 goes into 180. 30, and I still have that degree symbol. So that's negative 30 degrees. I can't say it enough. Pi radians is 180 degrees, or 180 degrees is pi radians. You want to use those conversion factors. Now let's look at standard position. An angle is in standard position if its vertex starts at the origin, right? So here's the origin. Right, the vertex starts here on all 4 of these, and its initial side is on the positive x-axis, right? So here's its initial side, initial side, initial side, initial side. To create angles, we can go counterclockwise like this one, or we can go clockwise. If you go counterclockwise, that's a positive amount. If you go clockwise, that's a negative amount. And now notice you can go just a fractional amount, or over here like C, you can go all the way around 360 or 2 pi and even more. Look at A and C. What do you notice about their ending value, right? They are ending, the blue line is in the same position. Those are called coterminal angles, right? Coterminal angles happen if their sides coincide. Again, coterminal angles will start in the same position, and their terminal side, here and here, end in the same position. It's just that one goes a fractional amount. This one is going to be less than 360 degrees, and angle C over here will go a complete 360 or 2 pi more. So this is going to be greater than 360 degrees. So how do we find coterminal angles? Well, we just add a full 360 once, twice, 3 times, or at 2 pi if we're in radians. So look at question 3 here. Find 2 positive and 2 negative angles that are coterminal with theta, right? Our angle theta being 30 degrees. If we start with 30 degrees and we add 360 degrees, or a full rotation, we will end in the exact same spot. That's going to be equal to 390 degrees. And then to get another positive coterminal value, we can add another 360 degrees. So that will give us 750 degrees. So 750 and 390 are 2 positive coterminal angles with 30 degrees. Now I bet you already know how we're going to come up with 2 negative values. You can see I started with 30, I subtracted 360, so 1 negative coterminal angle to 30 degrees is negative 330, and if I subtract another 360, my second angle will be negative 690 degrees. And we can do the same thing with radians, except instead of adding or subtracting 360, we are adding or subtracting a full rotation in radians, which is 2 pi. So if we start with pi over 3, I'm going to add 2 pi, but maybe instead of adding 2 pi, if I'm in terms of thirds, I might be adding 6 pi. So that's going to give me 7 pi over 3. And then for my second angle, I'm going to again add 2 pi, but that's 6 pi over 3 to give me 13 pi over 3. Can you give me 2 negative angles? Did you get negative 5 pi over 3 and negative 11 pi over 3? If you did, you are correct. And don't forget, our positive ones were 7 pi over 3. And if I add 2 pi, my second one will be 13 pi over 3. So remember, coterminal angles are just another full rotation, or 2 rotations, 3 rotations, in terms of either 360 degrees or 2 pi, whether you are in radians or degrees. So let's look at 2 more important formulas. Arc length is the part of the outer circle that's created by the central angle. So here is a central angle, and where it crosses the outer circle, or where it subtends the outer circle, that's your arc length, right? Because this creates an arc here. So if we're talking about radians, right? So in a circle of radius r, the length of the arc, right, is equal to r times theta, right? S is equal to the radius times theta. And theta is what we're using when we are in radians. Remember at the beginning of the video, I talked about the definition of a radian? Well, here, when our arc length, let me use that in a different color, is the same as the radius, and we divide those, we get 1. R divided by R is equal to 1 radian. So this represents an angle of 1 radian. Over here, we have an arc of 2R, or 2 radius. If I divide it by whatever my radius is, I get an angle of 2 radian. Well, that's what's used to create this formula of arc length is equal to the radius times theta. If we apply that to question 5 here, find the length of an arc of a circle with a radius 10, so I'm going to draw a quick picture of that subtends a central angle of 30 degrees. Well, what does that mean, right? Subtends means that angle intersects the circle, or it subtends the circle. So let me try to draw this a little bit better. I'm going to draw it bigger to start. Here's my radius. My radius is 10. And the angle that's created, and you don't need to be exact here, right? So this angle of 30 degrees, right, it subtends or creates this arc right here. I want to find that length of the arc. Now there is a formula using degrees, but I'm going to focus on using the formula that deals with radians. So to use this formula, that arc length, S, is equal to the radius times theta, I need to be in radians. So my 30 degrees, I need to change to radians. Remember our formula, pi over 180, or this is going to work out to be pi over 6. So if I exchange this angle right here to be pi over 6, and I use this formula, the arc length is equal to our radius 10, and that's 10 meters, times pi over 6. So my arc length is actually 10 pi over 6 meters, or 5 pi over 3 meters, right, if I divide by 2. So 5 pi over 3 is the arc length that's created by a 30 degree or pi over 6 radian angle. Question 6, a central angle theta in a circle of radius 4 is subtended by an arc of 6 meters, right? Our arc is 6 meters. Find the measure of our angle in radians, right? So again, helpful to draw a picture, right? I've got some sort of angle in here. I don't know what it is. I'm trying to find it. I do know that this arc length here is 6 meters, right? This represents 6, and my radius is 4. So if I just use my same formula, S equals R over theta, and fill in what we know, arc length is 6, our radius is 4 meters, and our angle is theta. Ultimately, theta is equal to 6 meters over 4 meters, which really is just 3 halves. So again, think about what that means. Our angle, right, is equal to 3 over 2, or 1.5 radians, right? We don't have to have that pi symbol in there when we're talking about radians. Finally, our last formula is for area of a sector, right? So we're talking about finding the entire area of a sector, and that formula in radians is area is equal to 1/2 r squared times theta. So again, this formula is when our angle is in radians. So find the area of a sector. Central angle is 60 degrees. So again, I can draw here is roughly 60 degrees. But again, I need that to be in radians. So 60 degrees times pi over 180 will be equal to pi over 3 radians. So I can change my 60 degrees here to pi over 3. I know the radius is 3 meters. So if I use this formula, area is equal to 1/2 our radius squared times theta, and that's pi over 3. And don't forget, our radius was in meters, so that's really 3 meters squared, because we'll come back to units in a second. So if I work this out, I'm going to get 1/2 9 meters squared times pi over 3. If I simplify this, the 3 here will cancel with the 9, and I will have 3 over 2 pi meters squared. And that 3/2 pi meters squared represents the area of this sector right there. So there are some basic formulas and ideas when we're looking at angles, whether they're in degrees or radians, and we can start to apply that to coterminal angles and also area of sectors and arc length.